friends. Taxmaster, welcome back to our channel Taxmaster. So, in the next part of coil, we will discuss about magnetic field and current flow. The magnetic field of a coil. Following mnemonics can be used to determine which end of coil from a magnetic north pole and which end from pole when the direct current flow through. The technical direction of current from the plus to minus pole is to be used as the direction of current. If you look at a coil and this is transferred clockwise from electricity, so there arises a magnetic south pole. If you look at a coil and this is against transfer clockwise from electricity, so there arises a magnetic north pole. If you grab the turn of the coil with your right hand in such a way that the finger except for the thumb are directed along the turns in the technical direction of the current, the thumb point is the direction of the magnetic north pole of coil. Inside a slim coil length much larger than diameter, the length which turned is in which an electric current flows. The magnetic field is created with the field length. The flux density resulting from the coil core different material constants and the magnetic field constants. Coil core have the task of increasing or reducing the inductance of the coil. The increase in inductance achieved by a magnetic core lead to a reduce in the number of turns or contactor length required for a certain inductance value and thus to a reduction in the interfacing electrical resistance of the coil. Cores made of electrical conductors such as copper and aluminum, which reduce the inductance by displacement of the field, are used to tune resonant circuit coil in the high frequency range used in FM tuner. Wire placed from eddy current in the iron block above and laminated sheet. Inserted into a coil of ferromagnetic properties increase the permeability and thus also magnetic flux density in the coil. Thus means that you can get by with sufficiently favor turns and thus with much less component volume in order to achieve the required inductance. Above certain material depend flux density, however, a dispersive saturation mechanism core because of the iron of coil in an electrical conductor and desired eddy current. So we search what is purpose of coil. So coil in electronic circuits. The purpose of coil is so we forward this side link and the coil in electronics. So we search this. So here we learn that and how to generate current with a wire coil and So please, what is the purpose of inductor or coil? Depending on the values of capacitor inductor, the energy from the capacitor will be delivered in a pulse of sine wave around 10 milliseconds long. Depending on the values of the capacitor inductor, the energy from the capacitor will be delivered. The diagram you have in is fairly primitive. The dangerous beside is still connected to the AC source. When that matter generating and shaping the pulse, when you shape the pulse also appear to outdated. So here is a related article that in circuits. So we search this and the result is that how electromagnetic coils work. So here is the related answer of our questions. A wire coil is an electric conductor with one or more turns designed to produce a magnetic field. This is commonly used to increase the strength of a magnetic field. The more turns of wire on the coil, the stronger the magnetic field will be. The magnetic field generated by the separate turns of wire will all pass through the center of coil, producing a strong magnetic field. Moving charged particles create magnetic field. This was first observed in early 19th century during an experiment. It was observed that when an electrical current flowed through a wire, a nearby compass would change direction. When the current was turned off, the compass would go back to its original north alignment with the earth magnetic field. So the experiment concluded that electrons moving through a coiled wires create a magnetic field, something that does not exist when the current was turned off. Charged particles create magnetic field only when they are moving. The experiment done in 19th century shows that a wire carrying an electric current is actually a magnet. Since the electrons all move through the wire in one direction, there is a well-defined magnetic field surround the wire. The strength of the magnetic field is proportional to the amount of current flowing through the wire. Increasing the current will increase the strength of the magnetic field. When there is no current flowing through the coil, there will be no magnetic field as well. The number of loops of the wire also affect magnetic field. Its strength is directly proportional to the number of wire loops added. In other words, increasing the wire loop will increase the strength of wire magnetic field. If the current is flowing clockwise around the coil, then that phase of coil will be the south, and on the other hand, if the current is flowing counterclockwise around the coil, then that the phase of coil will be the north pole. Coil of wire that acts like bar magnet with a distinct north and south pole. Every time an electrical current passes through the coil is called electromagnet. What are electromagnets? Electromagnets are magnets. Those magnet field is produced by an electric current. It displays a magnet attachment to other magnet object when a Electric current is passed through them. We can also control and switch on and off the power of its magnetic attraction. How to make an electromagnetic? To create an electromagnetic, you have need the following: magnet wire, an iron nail at least 3 inch long, dry cell battery, electrical tape, wire stripper, thumbtack, and paper clip. So this is the diagram how to make a coil, and you you will make a home experiment by this. Be careful about to choose the polarity of the battery. Using the material above, then following simple diagram, do the following: wrap the magnetic wire around the iron nail and leave 3 inch of wire loss at the end. Make sure that the wire is wrapped tightly, leave no gap in between. After wrapping the entire nail, cut the wire, leaving using the wire stripper. Remove the insulation of magnetic wire and expose at least an inch of bar wire. Do this for both ends of wire. Attach one end of wire to the positive terminal and the other end of negative terminal. Use electrical tape. Wrap both ends of wire and the terminal of the battery. Test the electromagnet by placing the thumb track and clip near the nail. Observe if nail attract them. Produce electromagnetic need to allow the fully wire that composed of fully annulled electrically refined copper. A magnetic wire winding wire is an isolated conductor used to interchange electrical energy with the magnetic energy. Usually it is coated with a copper or aluminum with a thin layer of insulation. It has three types: enamel wire, conductor wire, and the combination of two. They are commonly used for inductor, motor, potentiometer, electromagnet, and other applications that require tight coil of wire. Ferromagnetic material or element that can easily magnetize and are usually made from steel, cobalt, nickel, alloy, and soft iron. Ferromagnetic material respond strongly to magnets. Subjecting this material into a magnetic circuit will result in a more concentrated and denser magnetic flux, which then amplifies the magnetic field caused by the current in the coil. The magnetic field created by an electron can affect the orientation of the field made by the neighboring electrons, producing a magnetic domain. This is where all the electrons have aligned electromagnetic fields. A magnetic domain is an area within a magnet material when magnetization is in uniform direction. This is responsible for the behavior of ferromagnetic material, inducing voltage and current with a moving magnet and a stationary coil. Faraday's law of induction states that a changing magnetic field will produce an electromotive EMF force in a loop wire.